Hello everyone and welcome back. Today we're going to be simplifying these expressions using conjugates. So in this case here, we have a root b plus c root d. That's the conjugate of a root b minus c root d, and also of course vice versa. Right now, the other thing I want to mention is how do we actually simplify the following? Well, we need to essentially multiply the numerator and denominator by the conjugate of the denominator, because as we know, it is considered not in simplified form if we have a radical sign in the denominator. So for example, with this first one, we have this root 2 in our denominator. Here we have root 7 in our denominator. Here we have two radicals in our denominator, and here we have root 5 in the denominator, and all of those numbers need to go away. Well, not necessarily go away, but they need to not be in radical signs in order for us to be able to continue. Okay, so what we're going to do is we're going to multiply numerator and denominator by the conjugate. So in this case here, the conjugate of the denominator is 3 plus root 2. And then we're going to, of course, multiply the numerator by the same thing. Now, something else to keep in mind is we must use the distributive property in our next step. So root 11 needs to be multiplied by 3 and also by root 2. So we're going to have 3 root 11 plus root 22. And now neither 11 nor 22 have are able to be simplified any further than that, because neither of them have any factors that are perfect squares. So if either of them had any factors that are perfect squares, including them being a perfect square themselves, then we would be able to simplify this even further on the numerator, but we can't. Then in the denominator, we're going to use the FOIL method here. So we are going to get 3 times 3, which is 9. Then we're going to do outer, which is 3 root 2, right? So plus 3 root 2. And you might be thinking, oh, but there's a radical still in the denominator. But the great thing about the conjugate is once we do outer and inner, they always cancel each other out. So if we do inner, we're going to get negative 3 root 2. And so these just end up canceling to 0 in just a moment here. And then we have minus root 2 times root 2, which is minus 2. So that's overall going to be 3 root 11 plus root 22 over 9 minus 2, which is 7. And there we go. There's our simplified form. And keep in mind that because these conjugates always give us this difference here, right? If we are multiplying by the correct conjugate, we can even just ignore outer and inner because they will always cancel out. I would recommend for the first few times making sure you specifically show outer and inner so that you can make sure that they actually do cancel out and that you've chosen the correct conjugate. But sometimes those terms will be ignored just because they are bound to cancel as long as we've done the problem correctly. Okay, let's try a second example here. 9 over 3 plus root 7. So I'm going to multiply top and bottom by 3 minus root 7. 3 minus root 7. So that's going to give us 27 minus 9 root 7 on top. And then on the bottom, I'm going to get 9 minus 7. Right? Now, why is it 9 minus 7? I just want to clarify why. Well, 3 times 3 is 9. And then we do outer and inner. So outer would be 3 root 7. Inner would be outer would be negative 3 root 7. Inner would be positive 3 root 7. And then last would be negative root 7 times root 7, which is just negative 7. And so that's why we have that. And then, of course, 9 minus 7 is 2. So I'm just going to rewrite this where we just do that last quick simplification there. The only thing left in a radical sign is the root 7, and that can't be simplified further. 7 is prime, therefore it doesn't have any perfect squares other than one, of course, that are factors of it. Okay, let's try this next one here. So for this next one, I'm going to multiply by 10 root 10 minus root 3, like that. And then we're going to do 6 root 10 minus 6 root 3, like that. And then here we're going to do 10 minus 3, because again, outer and inner are going to cancel each other out. We're going to get plus root 30 minus root 30 with outer and inner. So we can just skip those. And then we have 6 root 10 minus 6 root 3 over 7. So again, we got rid of that denominator that we didn't want. Or I should say we got rid of the radical portion of our denominator, which was the whole goal. All right, let's do one more. We're going to multiply both by the conjugate. So root 5 plus 1, which gives me root 35 plus root 7 over 5 minus 1, which is just going to be root 35 plus root 7 over 4. And so there we go. There's our answer. As always, feel free to let me know if you have any questions in the comments below, and we'll see you for the next one.